Okay, for example 6, Paul is training his horse to run the course at a pace of 4 meters per second or faster. Paul rides his horse from D to C to E to B in 1 minute and 30 seconds. The figure ABCD is a rectangle. Did he make his goal? So let's plot his course. So he goes from D to C to E to B. So that's his course that he's going to run. He wants to go 4 meters per second or faster. It takes him 1 minute and 30 seconds to go that distance. So first off, let's look at how far did he go. All right. So how far is it from D to C?
192.
192. Now, the other two are a little bit more tricky, so let's focus on that. This is a rectangular course. It says figure ABCD is a rectangle, so they told us that. And since it's a rectangular course, I know for a fact that AD and DC are right angles to one another. I know that AC is the hypotenuse of a right triangle. So I'm able to find the length of AC here using the Pythagorean theorem, right? So let's just call the length of AC, we'll call it X. So I know that 80 squared plus 192 squared should equal X squared. The two legs, the two sides make the right angle squared, added together equals the hypotenuse squared. 80 squared and 192 squared are rather large, so let's just get those in the calculator. So 80 squared and 192 squared, 6,400 and 36,864. So if we add those two numbers together, X squared is 43,264. Let's do a quick check on the calculator. So plus 6,400, yeah, 43,264. So X squared equals that number. How do I find X? So again, X squared equals that. How do I find X? Square root. Okay, so I'm going to take the square root of 43,264. That comes out to 208. X equals 208. So I know that AC is 208, so I know also that DB is 208, right? Because it's rectangle, the diagonals are congruent. And if AC is 208, how long is EC? That's 104 meters. And then EB is going to be the same length then, right? So looking at this path that he's taking, he's going 192 meters from D to C, 104 meters from C to E, and then another 104 meters from E to B. So if I add all those up, 192 plus 104 plus 104, the path is exactly 400 meters that he's going to go. Now the speed that they want is 4 meters per second or faster. All right, so his current speed is how far he went divided by how long it took him, right? How far did he go divided by how long it took, right? So the fact this says meters per second implies that I want this to be meters per second also. Well, 400 meters is how far he traveled. How many seconds is 1 minute and 30 seconds?
90.
90 seconds. Okay, it's very important that we have the proper units when we're doing this, but that's in general how to get an average rate. Anytime you're talking about how fast did somebody go, if you want the average speed of a person, you just figure out how far they went, how long it took them. If you know those two facts, if you take the distance divided by the time, that's how fast they averaged. So if I do 400 divided by 90, we get that his speed was 4.44 meters per second. That was his actual average speed on the course. We wanted 4 meters per second or faster. 4.44 meters per second is faster, right? So did he make his goal? Yes. The actual answer to the question is yes, right? But again, the work demonstrates the reason why it's yes. So I'd like to obviously see your answer. If it's a yes/no question, give me all the work to demonstrate why it's true. All right. So that's how we do that. So again, Pythagorean theorem will be usable and probably pretty typical in these problems when you're trying to find missing pieces, because we have all these right angles. So expect that to be used quite a bit. And then again, just these properties of rectangles and squares will come into play also.